Basic codes for most standard ball bearings are 4-figure or 5-figure numbers. That's beside the manufacturer name. So SKF and then 4 numbers, SKF and 5 numbers. If you see a 4-figure code, so 4 numbers code, the first figure or the first number indicates the type of rolling elements. And the types of rolling elements, they are set with standards, ISO standards. So, for example, first number for deep groove ball bearing will always be 4. For tapered roller bearing, the first number will be 3, and so on. So these numbers are set standards. Again, first figure indicates the type of rolling element. Second figure, second digit, indicates the service weight, outside diameter, and width. So one number indicates all 3 dimensions. And this figure ranges from 0 to 4. And to understand this, the service weight, we're going to go back to page 26. And in figure 45, as you see in service weight, there are 4 digits, 0, 1, 2, 3, and 4. So by looking at the figure, you can see that this is kind of this bearing on the right, number 4, is beefier or thicker, wider than the bearing with service weight of 0. So basically what service weight indicates is for a given diameter of shaft, bearing with service weight 0 will take less load than the bearing with a service weight 4. And the only difference between those 2 bearings for the same shaft size, so both bearings, number 1, service weight 0, and service weight 4, they will fit on the exactly same size of shaft, for example, 2-inch. But compared to when you compare these 2 bearings, bearing with service weight 4 will be beefier, or it's going to be wider, and OD is going to be larger as well. Therefore, it will accept larger loads in service weight 4. And that's indicated in the second number of the bearing code. And the last 2 numbers, third and fourth numbers in a 4-figure code or for 4-digit code, bearing code, they indicate bore size. And again, we have to jump to a different page in the same manual to describe this. And I just jumped to page 27 of chapter 9, and you need to understand how this code is being used or how it's broken down. So you must understand this because this is very important. So up to 20 mil, the bore of the bearing is designated as 00. So last two digits or third and fourth digit, if it shows 00, then the bore size is 10 mil. So if I measure the bore size or the inner ring size, inside diameter, it will be 10 mil. If you see 01 stamped on the bearing last 2 digits, then it means that the bore size is 12 mil, and so on. So if you see a bearing with number 6003, 03 last third and fourth digit means that the bore size is 17 mil. So there is it's not that easy, but you have to understand how the bearing size is classified. So there's an example, 6200 ball bearing has a bore off. So I cross-reference last 2 digits to the table here. 00 means 10 mil. Okay. Then this is again about the bores because last 2 digits, it's all about the bore sizes. So for bearings from 20 mil to 480 mil, to find the bore size, you need to multiply the last 2 figures of the bearing number by 5. So as an example here, you will see 6204, last 2 digits 04, so it passed 03, so it has to be bigger than 17 mil. So that's the bore size or the inner ring size. So therefore, you multiply by 5, and 04 multiplied by 5 gives you 20 mil. So this is a ball bearing service weight 2, and then 20 mil bore. And then anything above 480 mil bore size, then the bearing size is directly included in the bearing number, and the example is shown here. Okay, so I just went back to four-figure code explanation, and let's look at the example. So example 1, you've got SKF 6208 bearings. So this will be all stamped in the bearing. So again, SKF indicates the manufacturer, NTN, SKF, and so on. Number 6 is Conrad, or single row deep groove ball bearing. So that is a code set by ISO. Again, I'm going to show you this table. So that could be found on any website. Number 6, it says deep groove ball bearing single row, and Conrad is just another name for deep groove ball bearing. Now 2 is the number 6 after 6, so that means service weight. Light, and you have to go back to the explanation of service weight and see. So service weight is 2, so the dimensions automatically set by the code are going to be for this type of for this size of bearing as far as OD and width. Then next is the bore size. As we discussed previously, 0.8, you have to multiply by 5, which gives you 40 mil bore size. And why is it multiplied by 5? Well, you just need to keep in mind, or you have to basically memorize it, that anything above 0.3 has to be multiplied by 5. It's just the way it works. Okay, example number 2, SKF 6308. Again, SKF is the manufacturer. Now, when compared to 6208 and 6308, very close numbers, right? So the bore size are going to be the same. They're going to be 40 mil bore because it's 0.8. It passed 0.3. It has to be multiplied by 5, so 40 mil. 6, again, first number, it just indicates that it's a Conrad bearing, exactly the same, deep groove ball bearing. Now, the difference between 2 and 3, and that difference comes from the service weight. And as you see in this explanation, service weight of 3 and 2 are different, even though they fit exactly the same shaft size. But number 3 bearing, service weight 3, is going to be heavier or beefier, as I usually say. So it's going to be wider and larger OD, so it will accommodate larger loads. Next is a 5-figure code applicable for bearings, classifying bearings, and this is where it gets a little bit more complex compared to 4-digit code or 4-figure code. And I would like you to read the writing in green. This is there was a discrepancy in Millwright manual regarding the code in black, so that's what you have in your Millwright manual. And as I was trying to figure out the difference between what they're saying in example 3 and 4, I actually came across some discrepancies, and I've contacted the manufacturer of NTN bearing, so it's the same bearing manufacturer. And in green, this is their explanation of the same bearing given to us in Millwright manual, which seems to be incorrect. So if you could just look at the NTN in green and see if it makes sense to you, because the last 2 digits again is the bearing code. Bearing bore size, 4th and 5th figure indicates bore size. So last two figures and relate to the same idea, multiplying by 5 after 0.3. And other than that, it's slightly different from 4-digit code. And therefore, I'd like you to read through this highlighted in green and see if it will make sense to you. So this is the first page. You can pause it and read it, and this is going to be the first page. And so when you're reading this, please go by green description of the same bearing in millwright manual, but coming from the manufacturer. Five-figure code does get complicated, and as long as you can understand the idea behind four-digit code or four-figure code, you should be good in identifying bearings, because most bearings, or a lot of bearings that you'll be replacing, are of four-digit code. Another letter you may see in the bearing, besides the manufacturer identification, such as FAG, you may see a K, letter K. So letter K means that the bore of that bearing is tapered. So remember, K is standing for taper. And also, if K is by itself, then by default it means the taper is 1 and 12. Okay, so K by itself in this bearing 6208K, it means that the taper of the inner ring, or the bore, is 1 and 12. And if it says K30, it means that it's 1 in 30 taper of the bearing. So if this said 6208K30, then the bore, or the inner ring of this bearing, would be 1 in 30. It's a ratio. Another letters to memorize that are used in bearing codes are letter Z or Z, and usually it's at the end of the code, and it indicates a shield. So we discussed shields and seals in the bearings. So letter Z is a shield, and RS means rubbing seal. So that's a seal, RS. And if you have two Z's, two Z's at the end of the code, it means that the shield is installed on both sides of the bearing. If you have two RS, then you have indication that the rubbing seal, RS for rubbing seal, is installed on both sides of the bearing. And then another letter you may see is P number, and it indicates tolerances from P2 to P6, where P2 is the smaller tolerance and P6 large tolerance. And it's basically deviation from nominal in microns. So how exactly or how precisely the bearing is manufactured